Good morning, everyone. Really excited to be here in Singapore again. I used to call this my home not too long ago. Thanks for all coming in. This is, by the way, the first AWS TechFest globally, everywhere in the world. We've never done this anywhere else. And Shantanu already hinted at that. Why AWS TechFest? Last year we had our AWS Summit, and a lot of you gave us feedback around saying, we like your summit, very interesting stuff, but can you help us get a little bit more hands-on? Can you do some more boot camps? Can you do some more workshops? Can you help us understand how to use AWS? And we always like to say we listen to our customers, and we want to build services for our customers, but we also want to run events based on the feedback that our customers are providing. And as such, we decided this year we're going to attach one additional day to the summit, which we call the AWS TechFest, which we're here for today to learn, a skill enablement event. So take the chance to go to the workshops and boot camps later and really up your skills on AWS. And thank you again for the feedback, and I hope we can make this AWS TechFest the first globally and really successful event. Now, this event wouldn't happen if it wouldn't be for our sponsors. So I want to take the time to thank Intel, VMware, Datadog, and Veeam, our global sponsors, but also our Diamond, Platinum, Gold, Silver, and ISV sponsors. This event wouldn't happen without them, and they have great solutions out there that they're building out. So please take the time to roam around the expo hall and have a look at what they have to offer on top of the AWS cloud. Now, today this is a technical session, so I want to take you through the changing nature of software development. I brought a few demonstrations with me, a few hardware demonstrations. We got some robots and a few other things, so stay tuned on it. Now, if we think about software development, what is changing? The first thing that's changing is data has become increasingly important. We center our applications around data. We got to have data lakes, and we got to get insights out of it. We start abstracting our applications. APIs that we put around them, open source tools that we're using, SDKs that we're wrapping around them, microservices, and microservice strategy, of which we're going to talk about in a little bit. We need to build for many different devices, no matter if it's smartphones, tablets, computers, different operating systems, or different IoT devices out there, smartwatches. We got to build for all these devices and make it portable, which also allows us to have all these devices talk to each other, have a manner of distributed computing. And all of this is happening at an incredibly fast pace. AWS keeps adding new features. There are new technologies coming out every day. So how do we actually keep up with all of that, enable our skills, and build modern applications? So let's dive into that and start off with the concepts, the architectural concepts of how we want to build modern applications. The first thing that's really important, if you want to be successful, you want to have the ability to experiment. The more you can experiment, the more you can listen to the feedback of your users and your customers, the faster you can churn out new functionalities and features that allow you to be successful. But to be able to do that, we're going to use a software architecture and an application architecture that allows us to build independent teams that can move fast and agile. So what changes in that world where we need to move really fast? Well, we got to adjust the architectural patterns on the way we create our platform. We're going to look into how do we change our operational model so that we can focus on building our product, building our platform, rather than focusing on the heavy lifting of racking and stacking servers, for example. And we got to look into how do we churn out software fast and quickly and deploy as you build things out and test them out. Let's start with the architectural patterns first. You might have heard of this already, but I want to go through it and try to understand how we built that correctly in AWS. Traditionally, applications have been big monoliths, one big application that does everything. Everything is packaged up and we deploy it out. That doesn't really work very well. Every change needs to go a lot of control, a lot of teams work on the same thing. That never bodes well. So a good strategy is to say, could I split up applications into smaller pieces? And every small piece has its own little functionality, and the combination of those functionalities allow us to build your platform. The idea of microservices. Now, microservices have the benefit that we can develop them completely independently. There's a microservice that might do the login of your website. There's a microservice that might look at your fulfillment center stock. There's a microservice that might do your user sign-up. The benefit is that developers can work on their individual microservice itself. You can specify the functions that you have, and you can expose them to other microservices. You can wrap your own SLA around the microservice that you hold as a team and communicate with others accordingly. This allows us to be much more agile in the way we develop software. How do we tie that all together? Well, APIs and event-driven architectures. So APIs are generally the entry point to our microservices from the client side. But it can also be the entry point for other microservices that talk to your microservices on the platform. There's also the ability to have event-driven architectures. When something happens, I notify another microservice. And in yellow at the bottom, any microservice can decide on its own persistence, its own data store. So how do we integrate these things together? Well, if you look at it from an AWS perspective, for a client-to-service capability, we can make use of the Amazon API Gateway. It gives us an API endpoint to our microservice backend, fully managed. If we want to have an event-driven architecture, we can look at services like Amazon SNS or SQS, which allow us to notify other microservices or queue up messages for further processing as things are happening within your microservice architecture. The way we want to look at SQS, it's kind of a queue. SNS is kind of a pub/sub architectural model, publish, subscribe. And how do we orchestrate that? Well, if we use AWS step functions, we can wrap a logic around how things are happening between our microservices. Something happened, another microservice needs to get triggered, and with that, we need to call other microservices. Now, we can write a lot of code to do that, or we can use AWS step function, where we have little to no code to orchestrate what is happening. And I mentioned we gotta have different persistence depending on the microservice. Why? Well, depending on what your microservice does, you might have different SLAs, different functionalities. You might have different kind of scaling abilities. A functionality that you might have on your website needs to be able to drastically scale up and down, process millions of transactions potentially. So maybe I choose something like Amazon DynamoDB, a key value pair store that allows us to scale to any kind of amount of data or transactions. Or maybe I have documents and I can choose Amazon Document DB. Maybe I need an immutable ledger and I can use Amazon Quantum Ledger Database, Amazon Time Stream for time series, or if you have graph relationships, you can use Amazon Neptune, relational, Amazon Aurora, or RDS. Choose the right kind of data store for the microservice that you're building, depending on the use case, depending on the SLA that you wrap around it, depending on the requirements that you have. You need to choose a different data store. And now you're going to say, okay, Ollie, thank you. But that sounds like a lot of moving components. So that makes it really hard to operate that, right? I got to operate all these different things. Well, the way you want to look at that is we want to change the operational model on how we run our platform. So what I want you to think of is, don't think about servers. Don't be the cute little bear there trying to hug a server and say, that's mine, I build it, and I keep maintaining it. That's not the way we want to do our operational model. We can't iterate fast, we can't develop fast if we keep thinking about servers and boxes. And when I say servers, I even mean stop thinking about just running EC2 instances. For certain applications, that might be great. But when you can, try to go beyond that and think, how could I do it completely serverless? Now, if you haven't heard of serverless, it's the idea of saying, how can I run an application without provisioning any infrastructure or managing any infrastructure? How can I use services that automatically scale to any amount of traffic that I have against my platform, to any amount of data that I need to process? But it also means that you only pay for what you use, only pay for the storage you use, only pay for the execution time of your code. Never pay for idle capacity anymore, and don't need to think about how you pre-provision for the next 2-3 years. It automatically scales. And it should be designed highly available and secure by design. Those are the concepts of serverless. And I think we got a lot of people familiar with AWS. We had some good answers earlier in the question section here. So you probably have heard of AWS Lambda. When we talk serverless, AWS Lambda is the first thing that comes to mind. AWS Lambda allows us to run our piece of code fully managed in the AWS cloud, and it automatically scales to any kind of capacity. But serverless is more than just AWS Lambda. Serverless is an operational model. You build an application, think about how can I make my application as serverless as possible. You have pieces of code that you need to run for your microservices? Great, AWS Lambda is your friend. You have a container, or you containerize your platform? Well, then look at AWS Fargate. AWS Fargate allows us to run containers fully managed, completely serverless. But it also goes down to the data stores. If you use something like Amazon S3 or Amazon Aurora Serverless, we have complete serverless database capabilities now. We don't need to manage it, it automatically scales. We only pay for what we use. All the way to the integration part, services like SQS, SNS. You pay for the volume of transactions or notifications or messages that you have sitting in there, and it scales automatically. And many other services are serverless, not just the one listed here. So when you build an application, when you build something new, think about how could I use a service where I don't need to think about maintaining and scaling it. Sometimes that might not be avoidable, but if it is, you shouldn't manage things yourself. Let us do it for you. It makes your life a lot easier, and it allows you to run faster. And one thing that I wanted to highlight, which is very important in the microservice concept, we launched a new component in AWS Lambda as of reInvent last year, which is called Lambda Layers. Now, I mentioned Lambda allows you to run your piece of code, and we fully manage it for you. Well, sometimes if you run a piece of code, you have dependencies of other functionalities or modules that you might be building. Sometimes you might want to share that across different microservices. Lambda Layer allows you to do exactly that. You upload a layer once, and now you can easily share that piece of code across all your different Lambda functions that you run, across all your different microservices that you're building. Gives us a nice little separation of responsibility, and if you want, you can even share it through the ecosystems to other customers that could use your layer. Very useful if you're, for example, an ISV, partner or vendor who wants to build functionalities into your platform and provide it to other customers. So we had a look at the architectural patterns. We had a look at the operational model. How about deployment? How about we build something and then we deploy it out, right? Do we just upload code, SSH into a server and FTP stuff up? No, of course not. Right? We want to think about serverless models, but we also want to think about a model where we build code and we automatically deploy it out. How does Amazon do it? Amazon as a whole, when we develop code, we actually apply all of these components that I just talked about. We decompose into microservices. We actually call it the two-pizza team strategy. What does that mean? Well, the microservice team should never be bigger than the amount of people that you would require, or the amount of people that would eat more than 2 pizzas. So 2 pizzas should be sufficient to get everyone a little slice. So don't make the teams too big. That allows you to iterate quickly on their own little functionality. You want to automate everything. Anytime you do the same thing twice, think about automating it. The other interesting thing is about standardized tools, belts and suspenders, automatic templates, and automatic compliance and governance check. If you think about security, within a cloud environment, within AWS, we can think about security completely differently. We can create complete different setups of assuring governance and compliance when you deploy code out automatically. And treat infrastructure as a code. I said, don't be a server hugger, right? Everything in AWS can be treated as code, can be templatized. Whatever you create a template, now you can create it many different times. If you deploy a piece of software, run it out. If it doesn't run well, you just shut it down, you just remove it, and redeploy it back out. And I said automate, right? So automate that integration and build and deployment pipeline. You check in source code, you can use something like AWS Code Commit. You can then build it using AWS Code Build, maybe even integrate it with third-party tools such as And or Maven. It can then be deployed using AWS Code Deploy, and all of that can be orchestrated using AWS Pipeline. And then very importantly, we also want to monitor how the application runs. There are lots of monitoring capabilities, tools, and partners out there, and also services that can help you drive further, such as AWS X-Ray. So if you think about it, if I'm a developer, what has changed for me? Well, the first thing is, if we apply these architectural patterns and run completely serverless, we reduce the focus on keeping our lights on, right? We get inherent scale, we get inherent fault tolerance, we get inherent high availability without the need to actually figure it out how we do that at scale. We can run microservices with our own choices of programming languages, completely polyglot. I can choose the programming language and the data stores independently for every microservice, and every team can work on their own requirement. I might have a strategy to have the same data store across the company, but that doesn't always make sense because different microservices have different requirements, and this allows me to do an experiment independently within that microservice. And that really helps me to move a lot faster with less collateral as a team in those individual microservices. And it allows me to extend capabilities in that microservice and iterate really quickly. And so one of the other interesting things is the element of open source. Open source allows us to greatly build great communities, develop code, but then also experiment. And this strategy, again, allows us to experiment with lots of different open source projects within those microservices. Now, I wanted to talk also a little bit about open source, but I figured, wouldn't it be better to get the expert in? So it is my pleasure to invite up on stage Arun Gupta, our principal open source technologist of AWS, who wants to tell you a little bit about how we keep open source open at Amazon. Arun?
I'm very excited to celebrate my second-year anniversary today with all the best developers in the world in Singapore here. So I'm very happy to be here and sharing what we do at Amazon about open source. I'm a principal open source technologist at AWS. I work with a lot of teams across Amazon in helping them define their open source strategy. What is it that we should contribute, how we should engage with the communities in all variety of ways. Just like everybody, I have a Twitter handle. Feel free to talk to me over there. Let's talk a little about what are the motivations on why we do open source at Amazon. Amazon has 14 leadership principles, of which customer obsession is the most important one. Roughly 90 to 95% of our roadmap is driven by customers, feedback from you, of which the most important really is customer obsession, as we said. Now, we aim to build relationship that outlast any of us. A company like GE, which is a 140 years old company, said they expect them to survive on AWS for the next 140 years. That's the kind of motivation that drives us to contribute to open source because it matters to our customers. Now, innovation is, again, a key aspect on how we continue to build new projects for you. We contribute to projects that matters to our customers and help them innovate further. At times, it is projects that already exist in the community. Things like Kubernetes, things like OpenJDK, things like Linux, where we already contribute. At other times, there are projects which we build, and we see a gap in the community outside, and then we contribute to the open source. Those are things like Apache MXNet, where we were one of the biggest contributors. Firecracker. Those are the technologies that we have contributed out to the real world. And then, in addition, there are projects which matters to our customer, like Spinnaker by Netflix, where we build integrations for our technologies like Lambda and Fargate, so that it is very seamless for you to use Spinnaker as your CI/CD platform. Healthy communities is very important for the longevity of OSS. So we make sure that we contribute to the communities and continue to invest into them so that it stays relevant for you. A lot of the contributions from our teams across AWS and Amazon bubble up because we don't want to maintain an internal fork. We don't want to maintain a fork or an internal version. So upstream compatibility is fundamentally important for us to make sure that we stay relevant in open source. And oftentimes, open sourcing our source code gives us a lot more eyeballs, and what that means is a better quality and a better security for our customers. So something like S2N is what we released a few years ago. That's the reason it actually got a lot better security for OpenSSL. These are some of the projects across Amazon where we contribute to open source. Now, remember, these are only just a subset of projects, so it's important to understand that part of it. But the key part I want to highlight here is we have a very simple, streamlined process within Amazon which encourages employees to contribute to open source. And if you look at the range of the projects, it's a wide range of projects. This could be a specific language, say Python or Go, or it could be infrastructure like PyTorch, or it could be something like OpenSSL, or Lucene, or robotic operating system, a wide range of projects. Now, the way we engage in communities is multiple folds. If you think about communities, one of the biggest communities is foundations. Open source projects, a lot of the work is done in their open source repo, but they belong to a foundation. So something like Kubernetes belongs to Cloud Native Computing Foundation. So when I joined 2 years ago, my first question was, why are we not part of Cloud Native Computing Foundation? We have been helping customers build cloud native applications for a very long time, but this is where all the interesting discussions are happening as well. That's one more venue for us to participate. And there we go. So we are now, for over a year and a half, a platinum member of Cloud Native Computing Foundation. We recently increased our support for Apache Foundation, so we are a top-tier sponsor over there. And there are many other foundations that we are part at different levels. Another venue for community is all of these open source events, things like O'Reilly OSCON, or All Things Open, or language-specific conferences, so PyCon, or RailsCon, or RubyCon, or Community Leadership Summit. So now we are sponsoring all of these events quite actively, and what that means is we get a big booth over there and an opportunity to engage with the open source developers, hear their feedback, and bring it back, and then act accordingly. On the far right, what you see is, when we joined Amazon, when our team was created, opensource.amazon.com, the website did not exist. So our team basically worked on creating that website. That is the landing page where you learn anything and everything around open source across Amazon. We also have an active Twitter handle. So AWS Open is how you talk to us and communicate with us, anything around open source. And the thing that I am most excited about is our blog post. We have a blog on AWS, which is focused around AWS, open source. And this is for you, customers and partners and anybody else who's building cool projects using open source on AWS. As a matter of fact, 20% of the blog posts on that blog are by non-Amazonians. And that's what excites me more. And this year, what we want to do is we want to increase that number significantly. So I want to get more and more contributions from you. Let's talk about it. How are we doing with Java? Keeping Java open everywhere. Amazon is a big Java shop. We have thousands of microservices using Java. We started building Java from source, and we were happy with the results that we saw. But then recently, there were changes in how JDK will be distributed and available to customers, particularly security patches. We fundamentally believe that the language runtimes should be free. So we realized that we were solving an internal customer problem by building OpenJDK from source. But then when the JDK changes happened, we realized it's a customer need as well. So we actually produced an external binary distribution of it as well. So what is Amazon Corretto? We launched Amazon Corretto last year in DevOps. And it was a fun experience, particularly launching it with James Gosling, who's the father of Java. And so Amazon Corretto is a downstream distribution of OpenJDK. It comes in two flavors. There is Corretto 8, which is OpenJDK 8, or Corretto 11, which is OpenJDK 11. And we provide no-cost, long-term support to our customers, whether you are on AWS, on-prem, on desktop, or any other cloud of your choice, for a very long time. So for Corretto 8, this runs up to June 2023. And for Corretto 11, this runs up to August 2024. So if you are using Oracle JDK today, or any other hotspot-based JDK, I encourage you to download Amazon Corretto is a drop-in replacement. And that's what I use on a daily basis. And I've been a long-time Java developer. I was part of the JDK team back when it was created at Sun Microsystems. And Amazon Corretto is my default JDK everywhere now. Another place where we're trying to keep open source open is Elasticsearch. Recently, Elasticsearch made some changes. The open source project made some changes where the features that are required for enterprise deployment are not available in the open source version. They're only available in the proprietary version of it. Features like SQL alerting, monitoring, security, RBAC. We believe the innovation should happen in open source, and that's where we release Open Distro for Elasticsearch. This is 100% open source, and what that means is you are free to use, change, and distribute the code the way you like it. This is the definition that is provided by OSI. And it is fully community-driven. So we would love you to participate in the Open Distro community and let us know what needs to be done. This is a common African proverb. And as a long-distance runner, I completely connect with it. If you want to go fast, go alone. If you want to go far, go together. This is Amazon's promise. We want to go far in the open source world with you. So help us keep honest and tell us what is it that we should be doing, because we want to go far in this race. We are working with our partners, with our customers, with our developers to make sure we stay open source compliant and we continue contributing more and more to open source. If you want to talk to us more, as I said earlier, opensource.amazon.com is your one landing page. You can also engage with us at AWS Open. And last but not the least, I would love to see more and more blog posts of yours on our open source blog. Thank you.
Awesome. I always love these stories about how we want to keep open source open. And it's really core to what we want to do. Now, talking about open source, one other thing that I wanted to address is portability. Especially here in ASEAN, mobile devices are really important. Right? How do we build applications that can be ported across many different platforms? If we think about mobile, right, there are many different cross-platform frameworks, open source frameworks, that allows us to create native applications within different kind of mobile platforms. React Native, Ionic, others out there. But the key point here is that we actually move more and more towards different web standards. HTML5 is a great web standard that allows us to use JavaScript and other components to render different experiences in browsers and distribute them across just using a browser to all these different devices. You can go so far that you can even use WebGL to render complete 3D objects within your browser. Frameworks such as Angular or Vue and JavaScript really help us to abstract the complexities away and build great web applications that allow us to port it across. And that really helps us to do that client portability. But what about the backend portability? Well, we talked about the microservices, right? APIs that you wrap around it. APIs are web standards that allow us to potentially talk to any kind of backend service that might run serverless or in containers, which allows us to port that backend. Now, I figured it would be fun to try this out in a little live demonstration. So I'm going to encourage you to take out your phone, and you're going to go to this address, bit.ly/AWS Cube. Now, it will open up an interface. Don't do anything quite yet, but just open it up on your phone. And meanwhile, I'm going to do the same now here on my laptop. So we can just switch over to my laptop here for a second. And I'm going to load up an interface. And we're going to try to create a virtual piece of artwork, a virtual cube that you're going to select which colors you want to vote for. And I see votes are coming in. And now I'm going to use an augmented reality. Wow, that's going fast. There you go. I'm going to choose an augmented reality demo where I'm going to try to overlay this cube right onto my face here. So you see the live artwork, and you're creating that artwork, lots of transactions coming through, and we're filling up this cube. Now, this is a wonderful example of open source in action and web standards in action. We use an augmented reality JavaScript library here to overlay a cube onto a marker that I'm holding up here, and we're using AWS IoT to receive all these MQTT messages straight into my browser, and you can see all these votes per second that are coming in. I can see that green seems to be a really popular color, and you're voting really, really fast, which I love. Awesome. Thank you very much. All right, let's go back to the slides. So this is a good example of what I mean with web standards, because I didn't really need to do much. I just gave you an URL, and you immediately could interact and interface with me, which is a perfect example of how we actually distribute computing. These web standards allow me to send a piece of information, of software, to your phone that automatically connects to AWS IoT with an MQTT broker behind it, that then connects to my laptop, where I use augmented reality JavaScript libraries to overlay. So what has changed for me as a developer? Well, first and foremost, more and more devices are being connected, no matter if it's smartphones or tablets or laptops or smart speakers that you might have at your home, or other IoT devices or wearables, and the entire ecosystems that are being built around them. Any application that you're building nowadays, we expect it to be globally available with a global user base. But there's a challenge. The laws of physics are really hard to change. I would argue you can't change them. So latency is still bound by physical distance. So how do we build applications that are global while taking those laws of physics into account? Well, we gotta adapt a few strategies in the way we build our applications. We gotta think about how do we use globally distributed data stores? How do we move code closer to the edge? Some of the code that was powering that voting functionality was right on your device. We moved it to the edge, to the device itself. How do I handle intermittent network connectivity? If I'm on a mobile device, I don't always have network. It sometimes disconnects. So how do I handle that gracefully? And caching, right? How do I cache closer to the edge? And if you bring that back to AWS services, well, if you think about data stores, databases, you have a relational database. Amazon Aurora has cross-region replication capabilities. You can say, here's my database in Singapore, replicate all of that information also into the US, into Australia, into Japan. The same goes for Amazon DynamoDB, cross-region replication. You can write into all of those different regions where you replicate it. This is a fully managed feature. You just enable it, and now you have those data sets in different regions at the same time, allowing you to redirect your local user to the local data store so you can react faster to it. The same goes if you use a service such as Amazon S3, cross-region replication of that data store. Now, how do I route a user to the region that is closest to him, or which has the lowest latency? Amazon Route 53 allows me to do latency-based routing. That's not even geographic routing, it's latency-based routing. Choose the region which has the lowest network latency and go to it and use that local logic code and data store. So I get a better and faster experience for my end user. If I need to have some logic, which I might write in AWS Lambda, I can even move it to an edge location. One of our points of presence, POPs out there using AWS Lambda at the edge, where I can move logic to the POP location. And of course, I can also cache there using Amazon CloudFront. Now, if I build applications, web applications, mobile applications, one other interesting service that you have is AWS AppSync. AWS AppSync allows me to build web and mobile application and handle intermittent network connectivity really, really well. We can create interfaces that are responsive and collaborative user experiences, which are connected to my AWS cloud environment and automatically synchronize across the different applications if it's connected. And if it's not, it remains responsive when it's offline, but when it goes back online, it synchronizes accordingly. And the way we actually try to understand those data stores or build those data stores, we design them using GraphQL. So again, fully managed service that helps me to do that a lot better. And talking about distributed nodes and distributed compute and distributed information, one of the technologies that has been talked a lot about lately is blockchain. It's a technology that allows me to build applications where multiple parties really can record transactions, immutable transactions, cryptographically verifiable transactions across many different parties without a central authority. Lots of interesting applications that come out of it. And we also recently announced Amazon Managed Blockchain, and in combination with that, Amazon Quantum Ledger Database, which allows us to run immutable ledger databases with a central authority. Now, talking a little bit about blockchain, I think one of the interesting areas is things like cryptocurrencies or smart contracts. So it's my absolute pleasure to invite up on stage Sean Ray, our principal tech evangelist of Asia Pacific, and he's going to try to plug himself into the ether. Sean, please come up. How's it going, Sean?
I've got something over here for us to look at.
You get a little demo? I love demos. Demos are always good. Show me what you got.
All right.
So let's switch over to
switch
Sean's
over.
laptop. Awesome.
OK, so we just talked about getting into the ether. So one of the really common blockchains that you'll hear about is Ethereum. If you've traded Bitcoin, you'll often change your currency into Ethereum so that you can move it onto the exchange. And I'm actually running a full Ethereum node here in the background. And what you're actually seeing scroll past is the blocks that are processing from the live public Ethereum blockchain and the transactions that are contained in each of those blocks.
Lots of things going on there.
Yeah, so we're real-time ingesting this. And the idea is, you or I don't really know much about Ethereum. And what we want to do is we want to gather some insights from this data quickly.
OK.
So we need to get it somewhere. So we ingest it from the Ethereum network, and then we push it into a little pipeline I've built here. So we've ingested 130,000 Ethereum messages or blocks. We have used public subscribe to actually push it through the pipeline, and now we're using Lambda Serverless to actually process these blocks and put it into a Redis Elasticache node. And so what we're trying to do is we want to see what is going on in the Ethereum network. And like you, we don't know anything about Ethereum. So we want to dive into this data and try and see what some interesting things that are going on.
All right. Wonderful web application. You build AWS Amplify.
Yeah, so you talked about Amplify before. And the key benefit of Amplify is that it uses GraphQL under the hood. It builds the infrastructure for you. And it will allow you to push using WebSockets into your browser real time. So if we reload the network here, we will actually be able to see those live transactions coming into my front end, pushed with only a few milliseconds latency. If we just wait for the network, if you can all turn off your Wi-Fi.
There you go.
OK, so now we can see the transactions coming in. But we don't really know anything still. We can just see them counting up. You can see that we've done, in the last week, 1.7 million transactions. So really what we want to do is we want to get some insights from this data. So how about if we instantly visualize it in a different way? So here we have a heat map. This is of the current week, so there's only 3 days. But we can start to see, in the blue coloring, some different colors of where there's transactions basically focused. And so if we go to a full week, we can start to look back a little bit historically and see what the transactions are. So we can see by hour, it's actually pretty smooth, but we've got a few spikes. And we can see in a full week that there's actually some really hot parts of the Ethereum network, especially 3 p.m. On a Wednesday. And so this is in UTC time. And so something happens at 3 p.m. on a Wednesday that is interesting to us. So after a couple of minutes, we've loaded up the Ethereum network, and now we can see this hotspot. So what does it mean?
So let's dive into it a little bit further, shall we?
So if we look at that hotspot, it's actually the largest transaction going on in the network. And Ethereum actually has a real US money value. So if I go and show this and a pipeline to my CEO, he doesn't really care. He's like, great, I don't really care. You're processing transactions. If I've got some interesting transaction going on, like this 48,537 Ether, to give you an idea about the size of that transaction and why that heat map is so hot, that's actually 10 million Singapore dollars that someone transferred in that hot block. So now I can go and look up that address because the Ethereum network is public, and I can actually see that wallet. And I can drag out now all of the transaction that wallet has done, and I can put them into something like a graph database like Neptune, and I can start to see the graph around this person. Who is this person transferring 10 million Singaporean dollars of Ethereum every Wednesday? And so that's just a quick view of how to use some of this serverless technology to quickly gain insight from your data and answer some questions. And now we have an interesting person and an interesting wallet that we could go and investigate if we wanted to go further.
Awesome, Sean. And you know what I like about it is how you applied all these architectural concepts here. Build it completely serverless, use Amplify, build a nice little web application, use those standards, and use as an integration Ethereum now as a network that you plug in, which is really, really great. Thanks for that. Stay on stage for a second, because I need you to help me with a robot in just a little bit. Now, talking about different networks and connectivities, one of the other interesting things is IoT and also robotics. Now, if you talk about IoT, we provide you with a lot of different services that really help you to connect your devices, no matter if it's phones, smart devices, smart watches, different devices that you might have at home. But it's more than just connecting devices. It's all about, you know, what is the kind of piece of software that I run at the edge of the device? How do I secure the device? And there are lots of different services that can help you here. On the device software side, you might use Amazon FreeRTOS, which is an operating system for microservice controller. You might use our device SDK or our device tester. You have control services where you can control the flow of how messages are flowing. Use a thing graph, device management around it, or use AWS IoT Core to route your messages across. And of course also analyze that using our data services such as AWS Events or Sitewise or IoT Analytics to understand in real time what are the messages that are flowing in, or is something wrong with my devices, and you can act accordingly. Now we think IoT, connecting devices, one of the things that I can connect is a robot. And robotics is actually undergoing a fundamental change in the way we collaborate in that space, in the way things like the robot operating systems are being developed, autonomous mobility, we increase intelligence, put AI and machine learning onto robots, and that really has helped us to look at robots very differently, and they pop up in so many different industries, no matter if it's logistics, where we ship around packages, or agriculture, energy management, retail, hotels. There's even hotels here in Singapore where you order a bottle of water and suddenly a robot brings it to your room. There's really a proliferation of robots. And so one of the things that our customers have told us, Sean, was, can you make robotics a little bit easier for me? And so we launched AWS RoboMaker. And I know you want to talk a little bit about that for me, don't you?
Absolutely.
I outsource my job here.
So I love robots. I've been building robots since I was very young. And robotics is hard. Robotics is hard because robotics deals with the physical world. And we just processed 1 million Ethereum transactions, and that's all cool, but it's the digital world. It's easy to spin up things in the digital world and build things. In the physical world, we need to sink capital. We need to test our robots. We need to make sure that they're safe so that they don't cause safety issues if they're interacting with humans. And we also need to train them in simulation in a way that we're not going to lose our capital. So if you think about something like automated truck driving or automated welders, we need to be able to train those in an environment that is not cost prohibitive and that we can actually replicate the real world. And so at reInvent last year, we did 2 important things for robotics. So the first, in Arun's message, is we built an enterprise version and released it of ROS, the Robot Operating System. So there is now a free open source enterprise grade version of ROS that you can use in all of your projects, and you don't need proprietary technology that you would normally have to buy to do that. The second is RoboMaker, which is a fully managed service to help you build and simulate your physical world and have a digital copy of it for your robotics. So for instance, if you're building something that is driving around a field, or you're building a welder, or whatever it is, you can actually simulate that entire environment that it is going to operate in, and you can test it and run thousands of simulations without buying 1,000 of the robots, without having to worry about deploying it to the physical site, because the physical site could be remote, or it could be on an island, or it could be on a ship somewhere. And so with those concepts, we really want to make it accessible for people to build robotics. And I think the best way to demonstrate that, instead of talking about theory, is actually to show you a demonstration of that.
I love demonstrations, Sean. And so I brought with me here a little device. This is a TurtleBot tree burger because it's stacked up like a burger. It's an open source hardware kind of robot that I can self-assemble. There's a little Raspberry Pi in here. There's an OpenCR board. We got dynamic source actuator, which are the wheels here at the bottom, which allows me to drive that robot around.
So you've got a camera as well?
I got a little camera, which I attached to it myself. It's not part of a default package. I realized, oh, it's Raspberry Pi USB. Let's plug in the little USB cam. And then we got this little spinning device here on top. You know what that is, Sean?
Some kind of LiDAR, I suspect.
There we go. It's a LiDAR sensor. So a LiDAR sensor allows me to actually spin around as a laser that actually points out and looks at the reflection. And it allows me to detect objects or walls accordingly as it's spinning around. And this is really useful for things like SLAM, simultaneous localization and mapping of a robot. So trying to understand where you are and map out what are the objects that surround me and create a map on the fly. And so Sean, I figured it would be fun to try to create that map on the fly of a little maze that I brought here with me on stage.
I think we have a camera on the maze as well, so we'll be able to zoom in on the robot moving around.
Let's see if we can get the camera up here.
Okay.
There we go. Okay, let's put the robot in the maze.
And to Ollie's point before, so the LiDAR works a bit like the laser pointer I have on my clicker here. So I can shine it out to this chair and figure out that that's X amount of meters away. And the LiDAR is just sending out thousands of those in a circle, trying to figure out objects that it's actually bouncing off.
So let's have a look at this, because I run the robot operating system tools here, and I actually run the R visualizer here. And if you look at I'm just going to make this a little bit bigger here. If you look at, zoom in, if you look at this, you see the little green dots. The green dots is basically the objects that I'm detecting. So that's the wall, right? So what I can do now is I can map out what I'm seeing in real time. So what I'm going to try to do is I'm going to try to navigate the robot. And actually on top, you also see the camera. So let me start by actually moving that robot a little bit forward. All right, let's drive around. And as you can see, as I get closer to the corner there, whoa, don't run in the wall, you can see that it's slowly mapping out that maze. Right, if I zoom out a little bit more, you can see that it's slowly identifying what's happening here.
I quite like the bird's eye view and the jitter. Like, it makes me feel like I'm on board driving with this.
There you go. What game does that remind you of, Sean?
It's like Doom.
Doom,
basically
right?
the cornering in Doom, because you're doing it 90 degrees.
Turn around the corner. Is there a monster?
And demon, no.
No monster. Okay, good. Let's keep driving. Okay, and I can control it right now using teleoperation commands, using the robot operating system as message bus. And we can see that LiDAR is now slowly mapping out the maze for me.
So these are the green dots that we're seeing coming solid out the outside of the maze here.
Exactly. And now you see SLAM in operation here, because the green dots, when they stay for a while, I realize this is an object that is steady. It's a wall. And now I can map this out in real time. And now we basically mapped out the maze in real time here.
Okay.
And now the beautiful thing that I now can do is I can say, okay, let me shut this down here for a second, close my visualizer, and I'm going to load up my navigator. And because I know the maze now, I recorded it, I can actually start navigating in that maze. Let me just
okay, so before Ollie was actually driving that robot, I can see his hands on the keyboard.
And I will raise my hands in just a bit. And now you can see the LiDAR kind of detects walls, and we have the map that we previously rendered. But it doesn't know its position quite yet. So what I need to do is say, okay, here's your initial position. And I need to map that out so that, roughly my LiDAR correlates here to where the robot is actually right now, because the robot is roughly looking here. And now we can see we have the map roughly right. Now you also see a lot of small little green arrows. That is telling me where we currently think the robot is. Now, that's not very accurate, right?
Yeah, so the robot has no spatial awareness. It doesn't know that we just dropped it on that particular corner.
And so what we can do now is I can give the robot a little go and say, how about you navigate a little bit to the front automatically at this point in time, and try to figure it out. And you see how these little arrows start to concentrate?
I see that,
because we mapped the LiDAR information onto the map that we previously know about where we were. Let me give it a little bit more of a go and give it another navigational goal here.
So one important thing here is that in a self-driving car or in some kind of autonomous vehicle, we have to give it a goal. You don't get in your car and it just starts driving you somewhere. So here we have to give it some kind of, hey, you're in the maze, like we want you to go around this maze. But we're not actually driving it, we're just giving it a goal.
And it allows me to automatically spin the robot around. And you can see how LiDAR now allows us. You see how that map slowly concentrated onto where we actually are.
Yeah.
And this is really how autonomous navigation, the principles of autonomous navigation. We have a camera with computer vision. We also have the ability to use LiDAR sensors such as this, and then navigate in that space accordingly.
Cool. That's an awesome demo. And I think that really shows the power of something like ROS and also RoboMaker, where we can simulate the physical world. So if this was a big maze or this was a work site, we have actually now driven around it and at a scale size prove that we can train a model to drive.
Exactly. Train that model and then bring it out and deploy it to the physical world.
Okay.
Thanks a lot, Sean. Thanks for your help, and you're going to be back soon, I think.
Cheers.
Thank you. So one of the last things I wanted to talk about is also data centricity. I said earlier, as we build applications, a lot revolves around data. Data helps us to navigate. Data helps us to understand our customers a little bit better. But what has changed for me as a developer? Well, first and foremost, we need to be able to derive insights really quickly. Saying I get the report at the end of the month of what happened this month is not acceptable anymore, right? We gotta get real-time insights. We have more and more data that is coming in. Data is growing exponentially large. I like to say petabytes are the new terabytes, you know? So we have petabytes of data. How do you handle that amount and the complexities in the data structures that we have? And so the way we want to do it, we want to think about a few things. Never think about that I do it later kind of concept. I collect my data later, I analyze it later. If you build a microservice, if you build a platform, if you build an application, directly feed information into your analytics pipeline and directly read out feedback if you can, if there's feedback that exists so you can render the user experiences better. The other thing that you really want to do is don't think about a traditional warehouse. Don't just put a big box somewhere. Decouple compute and storage. Store your data in a storage service and do your analytics and analytics services. And if you're not sure how to store it, data transformation is cost-effective now. So don't worry about how you store data, you can easily transform it. In Amazon's, or AWS terms, I should say, this translates into use Amazon S3 as a storage component. Build your data lake in Amazon S3. Why? Because from there, all the other services integrate. I can easily stream new information in using my Datastores, Kinesis, or Elasticsearch, but I can also, and most importantly, get insights of that data using services such as Amazon Athena. Amazon Athena allows me to run a SQL query on Amazon S3. So I can run a SQL query on a storage service. How cool is that? I don't need to bring up some cluster and figure out how I do that or some Hadoop system. No, I just run it straight on. But there are obviously components about Redshift Spectrum that allow us to even run data warehouse operations straight from Amazon S3. That decouples compute and storage. I can store a lot of data cost effectively, and when I need to get access and insights into it, I can do so using those services. And when I start getting insights, I can say, how about making predictions out of this, right? If I know past performance data, maybe it makes sense to build machine learning models around it. And why do we use machine learning? Because it's now inherently present in most applications. I would argue every application moving forward now should look into how can I use machine learning to build a better customer experience, to be more efficient, to reduce waste in the way I operate, or even build complete new business models, right? Build a complete new product that wouldn't be possible without machine learning. And what I would like to say is, for everyone here in the room who's a builder, developer, IT professional, machine learning is now available for you to use easily and readily through many different frameworks, but also through many different services that we provide you. The way we want to think about it from an AWS perspective is we want to make machine learning and AI and put it into the hands of any IT professional, any developer out there. And we look at it threefold. The top layer are the fully managed AI services that we provide you with in the space of computer vision, speech, natural language understanding and processing, conversational interfaces, chatbots, or even personalization or recommendation engine or forecasting services. All of these are just an API call away. You make an API call, you get access to it, we manage and train these models for you, and you don't need to have a data science expertise or understand the machine learning component behind it. If you want to build your own model, you can make use of the middle layer and say, I use Amazon SageMaker. Amazon SageMaker allows me to train my own machine learning models on your own data, in your own account, but by using inbuilt machine learning algorithms that Amazon provides you, but also our partners provide you through the AWS marketplace for machine learning. And lastly, we also want to bring down the cost of both training and inferring from a machine learning model. By deploying different kind of infrastructures that are optimized for training and inferring from machine learning models, but also most importantly, we want to make any framework available for you to use and optimize it against the platform. You don't need to choose if you want to use MXNet or PyTorch or TensorFlow or anything of your choice. All of these frameworks are you're not only able to run those on AWS, but we actually optimize for those frameworks across the platform. We want you to choose the framework of your choice and be agnostic to it. And so one of the interesting reasons of why we make so many advancements in the AI space is the idea of deep learning. And so, Sean, why don't you come back up on stage? I know you know a lot about deep learning. Why don't you tell us a little bit about what deep learning is all about and how neural networks work? And then I'm going to prepare a little computer vision demo for you right there.
Sure, thanks. Feels like ages since we've been on stage together. OK, so deep learning. So if you go and you search at the moment for artificial intelligence and machine learning, you're likely to come across deep learning. It's one of those buzzwords. It is a research facet of machine learning. And if you have ever done an object recognition demo or heard about natural language processing or used one of those audio prompts where they say yes or no to continue the phone call, you are using some form of deep learning most likely. And so you probably interact with it on a day-to-day basis. And it's really built out of a principle in the 70s, developed by a guy called Hinton, which is the perceptron. So thinking about the neurons in your brain and how they transfer data. And you can think of a deep network as having layers. And the more layers that you have, which are like the perceptrons in your brain, you're passing your data through there to figure out an answer. And the more layers you have, the more accurate answer you get. And deep learning is really allowing us to take huge swathes of data. So before we talked about training that data, we train the robot by driving it around the maze. And now we are using that data to actually infer what is going on. And that's what deep learning is doing. So I think we should show you what that looks like in action.
That's right. So I can build cool computer vision models using deep learning.
Okay.
And so what I brought here with me is just a normal camera. I feed that information of the camera. It's a normal CyberShot camera here.
I feel like you're pointing it straight at me.
There we go.
Okay.
And I feed it into my laptop where I run a computer vision model. And you can see that computer vision model has been trained on some common objects. And it allows me to do object detection in real time. It's really reactive. This is using Darknet as a framework, which is a C framework that has been written by Joseph Redmond. Okay. And it's really interesting because we can do quick analysis of what's going on and do quick object detection here. You got a bottle here. And just to show you, this is not a made-up demo that we recorded yesterday. I also want to see how that looks like. If we zoom in a little bit into the crowd, lots of people, lots of chairs down here. Yeah, lots of people. That's how it looks from up here. Hello, everyone. All right, and so, Sean, what I figured is, wouldn't it be funny if I actually trained that model not just on these normal objects, how about some custom objects, right? So what I'm going to do next is I'm going to load up a second model that I pre-trained, and we're going to bring out some custom models that I have trained this computer vision model on. And let's try this out. Let's bring the camera. I think there's something coming out there around the corner. Let me have a look. What is this? Oh, wait. Oh, that's a unicorn. It's a unicorn that is coming out. I trained it on a unicorn, Sean. You see that?
Random unicorns.
See how it's actually realizing what's going on there? Computer vision model. How about over here? Oh, we got one more over here.
Bring them into the center.
Oh, Sean is in the way. You're blocking my little unicorn. There you go. See how easy it is to run computer vision? Feel free to pass to the crowd. It's okay to, let's see where the unicorns are going. And so Sean,
wait, Ollie. Sean, I feel like you have pre-canned this. How do we know this was not all defined and this is just a video running in the background and we've just rehearsed this perfectly?
What, you think I just train it? I just train it on unicorns? Is that what
you're
thinking?
I bought my own object.
You get one more object for me?
Yep.
What?
And it's not a unicorn.
Sean, what are you doing?
So, I'm a very big fan of the Silicon Valley TV show. And the only thing that matters about computer vision is hot dog or no hot dog. So is this a hot dog, Ollie?
I know you too well, Sean. You see, I know you would bring out a hot dog like this, but... Oh, wait, what is this? What is this? Wait, oh, a hot dog man! A hot dog man! I trained the model on the hot dog man too. Thank you very much. Thank you. Awesome. Awesome. Thank you. You see, Sean, I always preempt you. I know you'd bring out a big hot dog.
I'm still going to try and trip you up for the next few years. We'll keep working on it. So now you have seen a real-time deep learning network that has been trained and is now put to use here, where we're detecting people, we're detecting the chairs, and we're detecting the unicorns. So this is the type of technology that is available today and most companies can spin up and use.
Awesome. Thanks, Sean.
Thank you.
Thank you for your
Cheers.
help. Always important to have Sean bring up some inflatables for me. Thank you. Now, if you wonder how that just worked, we actually used an open source framework called Darknet, and we trained that Darknet framework on computer vision machine learning models using our P3 instances. With 100 images in just 5 minutes time, I was able to actually train it on hot dogs and unicorns and hot dog suits itself. And by the way, that model then was pushed onto my laptop on which that computer vision model is running. And so the next thing you might ask yourself, how did I go ahead and train that model onto unicorns? Well, I invited my unicorn to my office. And I took that unicorn around my office and I pointed the camera at myself. And I was recording every single move, and then I took a lot of frames to train it on top of it. And you know, it was quite funny because I brought the unicorn into the office and all my colleagues were looking at me like, what are you doing? Like, why are you bringing a big inflatable unicorn? And I was like, you know what? This is real science. AI, deep learning, neural networks, computer vision, serious business, you know? And they're looking at me like, oh my God, head of emerging technologies. Oh my God. And you know what? When you do that, how do you train it effectively? Well, you need to label it first. So you got to tell the computer vision model, where is that unicorn? So you take these 100 frames of your video that you recorded, and then you got to go ahead and label it. So you got to click and say, here's the unicorn, here's the unicorn, here's the unicorn, here's the unicorn, which sounds like a quite extensive task to do. And it is, because supervised learning needs to have annotation done like this. And computer vision is generally supervised. And so one of the things that our customers have told us was, can you make labeling easier for us? And that's why we launched Amazon SageMaker Ground Truth last year, which allows you to actually annotate your data sets through multiple things. The first one, provide you a platform for annotators to annotate your labeling data sets, which can be either way employees of your companies or your partners, or actually through our AWS Marketplace, one of our partners that helps you with the annotation. You can specify the job, and a human annotator will look at it and try to annotate it. And then we have an active machine learning model as part of SageMaker Ground Truth, which will try to identify what is being labeled. And if it identifies that that thing has already been labeled, it can be automatically annotated in the future. And for the ones that we can't, we push back to human annotators. And so the last thing I wanted to talk about, as we talked about supervised learning, computer vision. We haven't talked about unsupervised learning, but that's a great way to do clustering exercises, for example. But sometimes we just don't have the data available to train a machine learning model on. In that case scenario, look at the top layer of the AI services of AWS, right? They might help. But if you want to train your own model and you don't have data available, then reinforcement learning can be a really great technique. And so we wanted to put reinforcement learning into the hands again of every developer. And what is the best way to do that? Well, how about we create a little racing car? So that's why we launched AWS Deep Racer, which is a fully autonomous and 18th scale race car, really designed to help you builders out there to learn about reinforcement learning and autonomous driving. There's a camera in there, and we're using reinforcement learning with simulation in the cloud to learn how it should drive around that circuit. Now, if you want to know more how that works, there are workshops out there, 3 today and a few others. And we also have the Deep Racer League open in the expo hall. You might have seen it over there. So if you want to participate in the Deep Racer League, it's open for you to try to race your own car around the track and use reinforcement learning to train it how to drive. And the winners will be announced tomorrow at the actual AWS Summit at the closing. And the first runner-up will actually participate in our Championship Cup at reInvent 2019 in Las Vegas. So, in closing, I want you to think about how you build software and applications differently. Experiment. And the way you do that is by creating different kind of architectures, microservices, use open source frameworks and cloud services, and think about different operational models such as serverless. I want you to think about how can I deploy an application globally? How do I use the right service so that I'm set up for success to deploy globally from day one? And how do I make sure that I built the right kind of data lake, that as a developer, I don't just say, that's my data analyst problems, that's my data scientist problem. No, we should all be part of the data analytics process. And we got great services that can help you to do so. And lastly, focus what's core in your business. If there's something like serverless available, don't go out there and build servers unless you need to. Right? Focus on what's core to your business and invest a lot of time of experimenting there. Now, one last thing that I want to leave you with is, this morning and also this afternoon, we got wonderful breakout tracks. Please select the breakout track that works best for you. There are workshops and boot camps out there. We have a leveling system, level 100, 200, 300, based on your expertise of AWS. So if you're very new to AWS, go to maybe the level 100 sessions. If you think you're already an expert, great, then learn some more things in the level 300 session. We also got them in the afternoon. Look at the leveling. And if I clicked through this too quickly and you couldn't take a picture, well, we got the AWS Summit event guide. Now, the AWS Summit event guide, you can either scan this QR code or go to bit.ly/AWS TechFest 19. It will bring you to an interface. Please sign up with your email address, not the phone number. Use the email address because we'll send you notification of your sessions and the material to it via email. And it will provide you also the agenda, the floor plans, and the speakers' infos out there. Now, I hope this was insightful. Please go out there, learn. This is a learning and enablement summit here for you to learn, for you to understand how these things are working. So go out there and build great stuff on AWS. I want to thank you very much for your attention, and we're going to roll a little video of our AWS Hack Day going on right now in that hall. Thank you very much.